In this clip, we'll review some of the information given last lecture, and also I'll correct some of my typos. And we're going to be interested in atomic orbitals, but we will only be interested in the r squared, and d functions. And let me draw the ones that we'll be looking at in particular are 1s. So here's 1s, r, and s orbitals are the only orbitals that start at a non-zero value. They do not have a node going to the origin, and 1s has no nodes. R squared is just the square of that. So the square. But d is equal to 4 pi little r squared, capital R squared. And at the origin, the value of little r is 0. So when I multiply these two, the d function looks like this. And that's the correct picture for 1s. 2s. S orbitals, do they start at 0 or not 0? Put it in chat. They start at non-zero. There's a big node followed by a little node. When I square it, I get this. That's the r squared. And I'm going to draw this to scale now, so the d function is correct. There's the d function. The when you look at the d function for the 2s, it's 4 pi little r squared, so it starts at 0, and the second node is the big one. So that's the 2s. 2p starts at 0 or not 0. 2p has a node going through it. It has no nodes, so here's the r. The r squared looks pretty similar. And the d looks like this. Okay. Then we have the quantum numbers. Due to the Heisenberg certainty principle, what I call the certainty principle, which is actually even more important to us than the uncertainty principle in Chem 2070. You can know E for an atom, total energy, total angular momentum, directional angular momentum, and you can know mz, spin direction, angular momentum, spin directional angular momentum. You can know these simultaneously. Which means that we can know what's the quantum number that goes with total energy. Put it in chat. N. What's the quantum number that goes with L? Put it in chat. L. What's the quantum number that goes with LZ? ML and MS can be known simultaneously. And in fact, that sentence is responsible, it will turn out, for the shape of the periodic table. Okay, just to make sure we have the rules. N equals number of nodes plus 1. The mistake I had was that L can range from number of nodes. That was a mistake last time, to 0. So L can equal any number 0, 1, 2, up through n minus 1. ML can range from minus L to minus L plus 1 all the way to L, and MS equals plus or minus 1/2. And these are the facts from last time which we will need.